Hello again, it's Mr. Pete, your internet shop teacher, and this is tips number 859 entitled How to Knurl Part 1. So there'll be a two-part video. Now in the first part here I'm going to talk about knurls, what they do, the purpose of them, and I'm going to show you a lot of examples, and I'm going to show you the tooling and various things like that. And in part 2 I will actually do some knurling. Now, the reason I'm making these videos, and I've done this in a lot of other videos as well, I can see by watching videos, other people's videos, that some people are producing horrible knurls, but they don't even realize that they're bad knurls. They are not getting the crisscross diamond pattern, and they're still thinking it's okay. And I had the same problem at the high school when I was teaching, that kids were clueless, and they would come up and show me a knurl and it looked like a rat gnawed on their project, and they thought it was great. So I want to show you examples of good ones and bad ones and different patterns and all of that, so that you can make a successful knurl. I'm also going to dispel a rumor about diameters and pitch and all that. At least I consider it to be folklore and not true, but many people subscribe to that. I'll talk about that a little bit as well. So let's get started here by talking about the purpose of a knurl. But first, here are some examples of knurls that you will see in everyday life. They are omnipresent in the machine shop. They are ubiquitous. So let's have a look. Take a look at my magnet rack here with punches of various kinds. Look at all the knurls. Not every one of them, but lots of them. First of all, how do you pronounce knurl? Do you say knurl or knurl? So here's an example here of a ratchet with a knurl on it. But you know, this is a Knipex pliers. Or do you say Knipex? If you say Knipex, then the correct pronunciation is knurl. And here are some examples of the ubiquitous knurl. A couple of punches, a telescoping gauge, clamps, vices, chucks. There's a nice knurl, two of them. And then you're going to see these little set screw knobs everywhere that are knurled. You know, they talk about tactical items, so they put a knurl on there. Even though you got a tremendous grip right here, you don't really need a knurl, so those are, I think, decorative. But you're also going to see fake knurling. So this is plastic injected knurl. Gives you a good grip and beautiful appearance. And over here at the Atlas Craftsman lathe, you're going to see that there's a knurl on all three of these plungers here. But in fact, they are die cast. That is Zamek. It's hollow. So, and it looks great. It's a straight knurl, but of course it's, I guess you would say, a fake knurl, or it's made by a different process than what we're going to talk about here later. Let's have a look in this little drawer of mine in the tool chest. There are knurls on just about everything that you see in here. And so on. Same with this drawer. Look at the knurls. Everywhere. I love them. And of course, when I open my micrometer drawer here, you will see that there obviously is a knurl on every micrometer. Sometimes several of them. 1, 2, 3, 4, and they're all perfect knurls because they're made by the method that I'm going to instruct you on in this video series. And looking into this drawer, more micrometers and a tap wrench with a knurl and a straight wrench. And these gauges here even have a knurl on them. So I've shown you many examples, too many of them, so let's move on. And now I'm asking you viewers a question. Do you consider this a knurl? Or this? Okay, here are 5 purposes of knurling. There may be more. If you can think of other purposes, put it in the comments. Now I'm going to go over these one at a time, starting at the beginning. Be sure and watch these 2 videos and you will see the shop where I purchased these Brown & Sharpe knurlers. Purpose 1 of course, was to provide a better gripping surface on tools and other products. For instance, this micrometer. There's another one here on the lock. So those are for your fingers, but sometimes we have large knurls for your entire hand to grip. So that's really the main reason for knurls, is to provide a nice grip when you are working on your various tools or machines. Purpose number 2 is decorative, to simply enhance the appearance of a product such as these. This knurl probably isn't necessary. Even if that was just as slick as ice, it wouldn't make any difference. You're just holding it like this. And same here. I believe this is strictly for appearance, although we're getting a bit of a, well, see, that doesn't even come off there nor here. So I think it's just for appearance, and it does look great. Purpose number 3 is to enlarge a product with poor tolerances for press fitting. And I'm going to talk a lot about an armature here in a second, but first let me just mention that they used to knurl pistons on engines quite a bit to increase their diameter. Also, when a product is made perhaps undersized, you can enlarge it slightly with the knurl for a press fit, which brings me to this armature. When I was in graduate school, I worked for 2 years in Bloomington at Osborne Engineering, and the main product there were fishing motors, trolling motors. They made their own motors. And I worked on a South Bend turret lathe, and I produced probably tens of thousands of stainless steel motor shafts that went into an armature like this, and they purchased the stampings here, the laminations by the pallet, and they were pressed on, but in order to give them a good fit so that the lamination would stay on the shaft, we knurled it. And it was a straight knurl on the 1/2-inch stainless steel, about this long. And so I made thousands and tens of thousands of perfect knurls every time with flood oil on it. Never failed to produce a beautiful knurl, and it was done in a matter of, well, it was a rather long knurl, so perhaps 15-20 seconds to go on and off the shaft with power feed, and those knurlers looked like this. That's where the first one I ever saw in my life was this type of knurler on that South Bend machine. So that's another purpose of knurls, for press fitting. Many knurls are hidden. You never do see them. So inside each one of these knobs is a knurl, because when they injection mold these in a plastic machine, they start with an insert. I made a cutaway. You know I love my cutaways. So look at that double knurl there. And that prevents that brass insert, that threaded insert, from pulling out of the plastic knob, and that is true in all of these knobs and probably many, many other products that you or I never even dreamed of. So those are the purposes for knurling or knurling. Again, put it in the comments if you can think of another reason, or how do you do it. Now I'm going to talk a little, actually a lot, about different knurling tools. Let me start with this hand knurler, and I haven't used this in ages. You can see how dusty it is. Matter of fact, my wife was supposed to dust my shelves. I got to get after her. There's no excuse for that. But this is called the Knurl Master. Pretty old. I've had it for a long time. I'd say I haven't used this at least in 10 years, but by the way, there's a knurl right there. And this little handle goes on here. So you can hand knurl in the vise, almost like a pipe cutter. There are 3 rollers there, and here's some extra ones. These are straight ones, straight knurls, rollers, and those are diamond. This used to have a nice foam liner in here, and that disintegrated. They must be in cahoots with Mitutoyo. Okay, I'm about to insult or hurt the feelings of thousands of people right now, but I think most of you already know that I absolutely hate, dislike, I have an aversion for this type of knurler, which we sometimes call the bump knurler. And I'm going to show you some catalog pages now from both Williams and Armstrong. Now this is a Craftsman, but I believe the W stands for Williams. Correct me if I'm wrong. The head floats a little bit so you can get it centered. These are diagonal rollers, but you can get different diameters, you can get different pitches. Pitch simply means, is it fine, medium, or coarse? And it's pretty easy to change the rollers, but again, I don't care for these, and I have thrown, or I didn't throw them away, I sold most of these. Let me show you some examples in old catalogs, which I find intriguing. Okay, here's the Armstrong catalog from 1966. You can see that there's a full page of the Armstrong catalog devoted to their knurlers and the rollers. I'll put still pictures of some of this at the end of this video. This is the standard Armstrong knurler that you're going to see. As a matter of fact, I just showed you one. And there's also one with a revolving head, almost like a turret, that has fine, medium, and coarse. And I used to have one of these at the high school. I did kind of like it, but again, it didn't produce good knurls. In this close-up picture, which I think you will find interesting, you can see the different types of knurl rollers that are available. So in the diamond pattern, there are 3 pitches, fine, medium, and coarse. Similarly, in the straight knurl, there are also fine, medium, and coarse. Now this is a page out of the Williams catalog showing their knurlers and their rollers, very similar to what I showed you in the Armstrong catalog, because they were fierce competitors, of course. And then down here at the bottom, they actually show you some examples of these and how they could be used. And I think this is better than what they showed you. Matter of fact, they didn't show you any of this in the Armstrong catalog. I hope it didn't hurt anyone's feelings by criticizing this bump type knurler, but you can also buy this type, but this really isn't any different. And these aren't too expensive, but don't throw yours away because it can be used as a tool holder from this side. You can't cut this off and throw it away because I believe it's hardened. So anyway, I don't like these really at all. Plus, they're not self-centering like this type of head. So, but it's very rigid compared to using this in a lantern type tool post. I placed this knurler in the 12-inch clothing just for a little discussion here, telling you what I do not like and do you agree with me. But first of all, this knurler is probably the wrong size for this lathe. You saw in the catalog that they make these in, what, 3 or 4 different sizes, the same as they do regular tool holders. It would work, but when you have real large diameter work like this, it probably will work fairly well, but certainly not with more limber, flexible stock that is going to be pushed away from the knurler. There's tremendous pressure involved in knurling. So the work wants to flex, as I just said, and is terribly damaging and causes a lot of wear in the screws here, in the cross slide, in the screw and the nut. So it takes its toll on the machine over a period of time. Don't even consider trying to knurl real small diameter work. Of course, if you do, choke it way up, but sometimes we have a longer piece, but look at how much this flexes as I push on it, and the knurler would be doing exactly the same thing. Support it with a center if necessary. But I want to tell you right now that all of the knurled products that I showed you earlier in the video were not made by this type of knurler. It just is not done. In industry, they are always using this type of knurler. If you have evidence to give me that they are not using this, let me know. But this doesn't put any pressure up against the work. So these are just the cat's pajamas. So this is mainly what I am going to talk about. But let me show you a few other pinch type knurlers that Alaris and other fine companies made. This is the Alaris catalog 25 years ago, maybe even 30, but I did at one time own the number 19 Alaris pinch type knurler. Extremely high quality, very rigid, very, very expensive. I believe that I sold it at about the time that I came into possession of this. I decided never to use this type of knurler. Again, other companies make similar ones. Some of them just fit into a lantern type tool post, but let me show you a variation of this that Alaris has on another page. Am I telling you too much? And here's another Alaris tool, very similar to the one I just showed you. It's the AT19. I never did have one of these. This was $195 in 1990, so it is not affordable. But again, we call this a pinch type. I don't believe it is a floating type that some other companies sell, but if you ever come across one of these, pick it up. I'm not sure they still make them because this catalog is so old. Okay. Enough criticism, I promise, about bump type knurlers. I suppose some of you are getting mad at me, but I love this type. This is Brown & Sharpe. Other companies make these as well. I'm not sure they're still available. If you want one, Feebay is really your only possibility. But Brown & Sharpe made these, again, in 3 sizes. There's a smaller one. And I'm going to show you pictures in the catalog of this. And these, in fact, are the knurlers that I'm going to use in the follow-up video, part 2, on how to knurl. So I'm going to make diamond knurls and straight knurls. I'm going to show you how to set these up and all of that good stuff. These were never meant to be used on a standard engine type of lathe. Hey, I invented it. I did. I just plain and I've never seen anybody else do it, but these are really meant to be held in a turret lathe, as I said, but I will be holding it in the compound, on the regular tool holder that I have. Also, I'm going to attempt to hold one of these in the tailstock. I've never done that before in the follow-up video, but notice on this, each one of these has a range, which I'll show you. Let's say 5/16 up to 5/8 or whatever it happens to be. So these little, I'm not sure what to call them, can be adjusted in and out like that. And there's set screws here. There's an adjustment right here. And you can see that the rolls, they are straight rolls, not diamond, but you can produce a diamond knurl with them when this is set at 45 degrees. So it can be set at 0, at 30, and 45. I've only ever used 45. This is extremely rigid. In some ways you're limited to the length of work that you can knurl because we've got a hole right here that would allow you to go in a little way, but there's a step on it and the diameter is smaller out here. However, a piece of 1/4 inch or 5/16 could fit all the way through, I suppose. And I did make very long knurls, perhaps 4-inch knurls, in that armature job that I talked about a little earlier, and this one is made exactly the same. Here's a close-up, Brown & Sharpe. This is probably quite old, and this is model 20D. The larger one here, by the way, this is 3/4 shaft, this is 1 inch. This is the 22D. Very hard to read. This one's kind of beat up from being banged on and held in a vise and so on, but that does not affect its usability. Okay, this is a page out of the 1941 Brown & Sharpe catalog just before the war, and you will see here that the smaller one that I just showed you, the 20D, was $23.50. Adjusted for inflation, that is now equal to $477. So it was always an expensive tool, and for that matter still is. So at the bottom here is the larger one that I just showed you, if you're interested in seeing what the capacity and range and dimensions are. And then there was a smaller one that's on the top here. I really know nothing about that. I've never seen one, but it would be nice to have for your smaller sizes. Here is the 1938 Warner & Swayze Turret Lathe Tool Catalog Pocket Edition. So this is Warner & Swayze's version of a knurling tool, similar in appearance. They even show you the setup. This is the turret, the lathe bed turret that it is fastened in, and you can see the work there. And there are also 3 sizes available from Warner and Swayze. They are long out of business, and they give you dimensions and everything else that you would need here in ordering and probably to set the machine up. And there are some examples of what it can do. If I may, I'd like to show you examples of good and bad knurls. Now this is a stare-at micrometer. Look at the perfection of that knurl. There are little diamonds, each one easily seen, gives you a tremendous grip. Same thing here in the black color, and a little knurl right here as well. So those are great knurls. Now let me show you a bad knurl, but some people do not realize that they are making bad knurls. For instance, here's one. There's no diamonds there at all, but it would serve the function of giving you a grip, but it is not what a knurl should actually look like. And it has come to my attention that lots of men are unaware of that. Let me show you another bad one. Knurling was so difficult for students that after about 5 years of teaching, I actually gave up on knurling. I didn't have them knurl anymore because they had no results. Now later on, no good results. Later on, I did get the Alaris and I experimented, and we had better ways of doing it, but it took me a long time to figure that out. There was no YouTube back then. But look at this. As I was setting up here, now I've owned this for 40 years, genuine Alaris, bad knurl. But in 40 years I didn't notice it, so what difference does it make? Now here's another genuine Alaris, and the knurl is perfect. Generally all your knurls will be perfect and consistent with this type once it's been set up properly, and if the rolls are sharp and you're using plenty of oil or coolant, the results are consistent. I do not like to criticize other YouTube creators, but there are some videos that I've seen and some conversations that I've been in that said, well, the reason they got a bad knurl right here is because they didn't have it set up right with the pitch. In other words, they said that the diameter of the work has to have a relationship with the pitch of the knurler that you're using. I don't believe that at all, because there just is no way that they're going to turn something like this down. Let's just say this is 7/8 diameter. They're not going to turn it down first to some odd decimal diameter so they can knurl it. So I just do not buy that at all, but it is a very rational way of thinking and mathematically, but all right, you tell me what you think of that, but again, you will not fail. So when I bought these from Tom and Vic at that screw machine shop that I showed you a little bit earlier, if you want to take a look at that link, I told them about it. I said, Tom, now a lot of people say that you need a certain diameter and for this roller and that, and he actually laughed at me and said, I never heard of that. Now he's retiring, he's 65 years old, he's been in the screw machine business, probably made tens of millions of products with a knurl on it, and never heard of that little formula that I was just criticizing, I'm sorry. He almost laughed me out of the place, because we just set it up and run them, and they're all perfect. And he showed me scores of examples of what they had done in their shop there. In a very recent video that I did, and I hope you have watched it, I made this gear cutting attachment for the Atlas lathe, but one of the operations that I had to perform was to make this little knob with a knurl on it. So I had demonstrated in that video how to do that, so you can go back and watch that, although it will be very similar to what I do in part 2. Well, that about wraps up this rather long video, part 1, about knurling and knurlers. I hope you enjoyed it. I hope I didn't hurt your feelings. And be sure and watch part 2, where I will show you how to make perfect knurls every time, so there'll be no pouting. Another thing I wanted to say is that when you do make a project, if possible, put your knurl on first rather than last. You don't want to spend a whole day making a complicated project and then putting a bad knurl on there and having to pitch the thing or be ashamed of it. This is Mr. Pete saying so long for now. I'll see you on the radio.